Hello viewers, welcome back. Here we have two functions, 2x squared plus 4x minus 1 all to the power 6 and 3x squared plus 1 with the square root. We asked to find the derivative of each of these functions. To find dy dx, these functions are composite functions. If you are to do the first one here, what you could do is to expand this bracket first, color like terms before you differentiate. But you observe that if you want to expand this bracket, you're going to do it several times, and this will be a whole total waste of your time because we have power 6 here. So we're going to expand the bracket 6 times using binomial expansion, and that will take a whole lot of our time. So the solution to that, or shortcut to that, is what we call the chain rule. The rule you're going to do chain, you're going to chain x to u, then chain u to y. Here, we will say let u be equal to all that we have here, 2x squared plus what? 4x. 2x squared plus 4x minus 1. Therefore, y will be equal to what? U raised to the power 6, correct? We'll differentiate u with respect to x and differentiate y with respect to u. Here, x is a function of u is a function of x, hence the term the function of a function. This chain rule is also called the function of a function. So we're going to differentiate u here with respect to x. To do that, we'll not bring in dy dx, we'll bring in du dx. Du dx of this function will give you 2 multiply x to give you what? 4x plus, the derivative of 4x here is what? 4. While the derivative of minus 1 here is 0. So also, we will differentiate y with respect to u because u is a function of y. For that one, we'll write dy du. For that, that'll give us 6u raised to the power 5. Now, let's chain u to x as we have done, and then chain y to u. Finally, our dy dx, the chain rule, is equal to dy du times du dx. X is a function of u is a function of y, hence the function of a function. So we'll substitute our derivative for du dx to replace du dx and dy du to replace dy du. So our dy dx, our derivative for the full function, is equal to dy du, which is what? 6u raised to the power 5 times du dx, which is what? 4x plus 4. Having done that, we'll substitute the value of u to replace u here. U in our opening function was 2x squared plus 4x minus 1. So we'll bring it there to replace 6 brackets 2x squared plus 4x minus 1 to replace u multiplied by 4x plus 4. And that is your derivative. The second question, we're given square root of 3x squared plus 1. Number two, we have to find the derivative of this function, 3x squared plus 1. You agree with me that this is equal to 3x squared plus 1 raised to power half. Now, using the chain rule, we'll say let u be equal to 3x squared plus 1. Therefore, du dx will be equal to 6s plus 0. And that will give us 6x. Then again, y will now be equal to u raised to power half. Then to find dy du here, dy du is equal to 1 over 2 times u raised to power 1 over 2 minus 1. Quickly on this side, 1 over 2 minus 1 over 1, LCM is 2, that is 1 minus 2, that gives you minus 1 over 2. So 1 times u here will give us u divided by 2 raised to the power minus 1 over 2. Going forward, u here can actually come down so that the power here can become positive. You now have 1 over 2 u raised to power what? 1 over 2, which is equal to 1 over 2 square root of u, correct? Now, our chain rule, which is our derivative, is dy dx is equal to dy du times du dx. What is dy du? dy du is what? 1 over 2 root 2 square root of u times, what is du dx? Du dx is what? 6x here times 6x, and that will give us to be equal to 1 times 6x will give you what? 6x all over 2 root u. 2 here, 1, 3 will give you 3. That will give you 3x all over square root of u. And what is u in our opening question? U was equal to what? U was equal to, we have 3x divided by, u was equal to what? 3x squared plus 1. Remember, u from here, 3x squared plus 1. So this is the derivative of the function using the chain rule, aka the function of a function rule.